Hey everybody. Welcome back to density. Here's your third and final example. This time you're going to be solving for volume. The formula is still listed at the top so you can see it. D equals m over v, and the D stands for density. Mass is represented by an m, and v stands for volume. In the parentheses I have the units for each of those variables. We're going to solve this problem just like we solved the other two. We're going to first start by listing the different variables. So we need to find a value for density, a value for mass, and a value for volume. Now I'm going to look at the reading. The density of iron is 7.86 grams per centimeter cubed. I'm going to stop there since this is the word density and it's already giving me the number. I'm going to write it in right away. Then I don't have to go back and relook later. Now I'm going to continue with the question. What is the volume? Here's our question. What is the volume? I'm going to put a question mark this time at the variable v if the mass is 15.3 grams. If I take a look at my list of variables, I know that I'm solving for v. And I have density and mass. I'm going to write the formula. Density is equal to mass divided by volume, or mass per unit volume. If I take a look at this formula, the way that it is set up, density is by itself on the left-hand side. Therefore, this problem is actually set up to solve for density. But I'm not looking for density this time, I'm looking for the volume. Therefore, I need to do some basic algebra and rearrange this formula. You can rearrange after you plug in the numbers, but to be honest with you, the rearranging is a lot easier if you rearrange the variables first. You still use your algebra skills. I'm going to use a different marker for this so you can tell what I'm doing. The problem with solving for volume, which gives students a little bit of trouble, is that the volume is both a denominator and it is with the mass. So this is actually a two-part rearrangement. The first thing I'm going to do is to get this volume to no longer be on the bottom as a denominator. I want it to be a numerator. To do that, I'm going to make up a fraction. This is a fraction, and I'm going to place a v on top over 1. Since one v is a denominator and the other is a numerator, I can cancel these two terms out because they really equal 1. If I do this fraction, where I multiply this fraction by this side, I also need to multiply this fraction on the other side. What you do to one side, you do to the other side. This is kind of a mess. My suggestion is to always rewrite the formula real quick. It only takes a little bit of time so you can tell what you have canceled out and where things are now. So I have a v. I'm not going to write the 1, it's understood. I'm not going to write the multiply because that's also understood when the variables are next to each other. So v times d is equal to m. So if I take a look at my new formula, what I have done here is I did the first step, which was I moved volume to be numerator. I still can't solve for volume the way this is set up because volume is with density, and in order to solve for a variable it needs to be alone. I'm going to take my orange marker and I'm going to create some, or do some algebra to rearrange this to get v alone. I'm going to divide this side by d because the same principle up here, when one variable is a numerator and the other is a denominator, they equal 1, so I can cancel them out. If I do this division to one side, I have to do it to the other side. So I'm going to divide the mass also by density. Again, this is kind of a mess, so I'm going to rewrite it. So in the end, volume is equal to mass divided by density. The district is only going to provide you with the first arrangement of this formula. So you need to be able to use your algebra skills to rearrange for whatever variable is asked of you. This arrangement right here was rearranging to get V alone, get volume alone. And if I take a look here, I'm set up to solve for volume, so I'm good to go. I'm going to just put the little equal sign next to this fraction because these are equivalent, and then I just plug in the numbers. So mass is 15.3 grams and the density is 7.86 grams per centimeter cubed. This is quite a lot here. It's actually two fractions because 15.3 is a number and all numbers are over 1. And I'm going to move this camera a little bit so you can see the bottom. There you go. If I divide a fraction by a fraction, I'm actually going to multiply the fraction by its reciprocal. So 15.3 grams is over 1 times this other fraction, which is the density. The 7.86 is the numerator of that fraction, so the reciprocal will put it on the bottom, and that's a grams. And the 1 centimeter cubed is a denominator there, so it is the numerator. Now we're going to stop and pause and take a look at the units. This grams right here is a numerator and this one is a denominator. Therefore, they both cancel out for the same concept that we talked about up here. If I divide a gram by a gram, it's really 1, so I can cancel out my like terms. If I look here, there's only one unit that is actually left, and it's centimeters cubed, which is fantastic because I'm looking for volume and I have a volume unit. That gives me a good indication that I set up everything correctly, and when I plug this into the calculator, I do 15.3 divided by 7.86, and I get 1.95 centimeters cubed. We just solved for volume using the density formula.